say I had 2 stars. So let's triple star. What were the 2 stars? The 2 stars are 2 conditions that were ensuring the convergence of the inhomogeneous Markov chain. So ensures star for convergence of the genus Markov chain. And finally, chain will converge to the uniform distribution on set of Now, in practice, if you are really going to implement this algorithm, surely if you have already found something that is better than the current Z that you have generated, you are not going to discard that, right? So you will keep that, right? So you can actually create another chain here, okay? So every time, so your X chain will be there, but every time along with X chain, you create another chain called that say X star, where the best result you keep so far. That is what is called the elitist approach in annealing. I don't know why it is called elitist, but it's probably the elite is always going to be there or something like that, okay? So this is called elitism, okay? So when you implement it, you always implement it with elitism because so you are going to stop at some stage and then you are not going to report the X, you are going to report the X star because that's the best value that you have got. Okay. So if you have run your chain 10,000 or 1,000,000 times, then certainly you are not going to report just the last value. You will report the best value that you have gotten so far. That's why you keep the best value always. Okay. So it's like you sort of have 2 counters. Okay. In one counter, you have the X chain generated. For Z, you have a variable counter because this Z you don't preserve. Okay. You create a Z, based on the Z, you create your X, and then you discard that Z. You don't need that Z again, right? Because you are going to create a new Z and then you will see what is happening there. Okay. So you go on doing like that. Okay. So finally, the value that you will be taking is from the elitist chain, the one that gives the best result so far. And all the arguments that I have given you so far essentially leads to a final theorem that if you choose your beta n like this, then that elitist chain will converge to a minima. That will converge to a minima for obvious reason. Okay. So this is Markov chain Monte Carlo and use of it in an optimization problem. Okay. So for the remaining half an hour, I will try to show you a couple of applications of that in some 2 interesting problems. Okay. But before that, this might again be a good time to break for questions. Do you want to ask any question? You want me to clarify anything? Is everything clear or you want me to repeat something here? We can do that. Okay. As I said, I am going a little too fast because of the shortage of time, and that's why I have skipped some of the technical details. Okay. If you read, by the way, if you want to read about these things and the results, okay, you don't have to buy a book these days. Just search in the net and you will find hundreds of documents on this with the detailed proof. Okay. So there are a lot of materials in the net where you will find the details. Okay. So this is an old subject, okay? It is going on since the 50s. So there is enough research done, and there are a lot of materials freely available in the net, okay? So if you want to learn more, there are enough materials available there freely for you, okay? Do you have any question about what I have discussed? Yes?
The second method you talked about, this relative method.
Yeah.
So won't we have to face the risk of getting trapped into local minima in that case?
No. This is the best result so far. See, you are not getting trapped in the X chain, so you are okay. The result that you have in the X chain, in the elitist chain, the result is only better. It is the best result so far. See, there was a best result in the past, but because the chain kicks you out of the local minima, so if it is the local minima, you will come out and you will go to a better result. See, you are running the X chain, but you are always skipping the elitist chain. You are not running the elitist chain. The elitist chain is created from the chain that you are running. So you create Z and decide whether you keep Z or keep the original value. And that chain proceeds, and every time you retain the best result that you have obtained so far. So there is no issue of getting trapped into the local minima here. Any other question from anybody? Okay, so let me now give you a couple of very interesting applications of this in statistics particularly.